Hey everyone, welcome to math. Today we're going to be adding, we're going to be subtracting rational expressions. It's been a while since we've really learned anything and been together to learn stuff, but this is how it's going to look for a little while. And I thought, well, to be honest, I wasn't entirely sure if we left off on subtracting or adding, or even if we got to either. So I thought, let's just do both and relearn, refresh on how to do this. So the first thing we have to talk about when we're adding and subtracting rational expressions is way back to grade 7 when we were adding and subtracting fractions. So, for fractions, less complicated rational expressions, we can add these together. The key idea being the denominators are the same. 1 plus 4 is 5. Having bad luck with pencils today. Okay. So, 1/3 plus 4/3 would be 5/3. And that's kind of how that works. So, the next kind of level up way back in junior high was, well, what if our fractions, what if they are not the same? So 2/7 plus 1/3. Well, then we have to find a common denominator. So if you're understanding the foreshadowing that's happening here. To do that, we multiply the bases, or not the bases, I should say the denominators. Sometimes we'll say we'll multiply the bottom. So 7 times 3 is 21. So both of these fractions are going to be out of 21. What's really important to note is that we don't change the fraction whatsoever. In order to get 7 to be 21, we're multiplying the bottom by 3. And we also have to multiply the top by 3. So we're multiplying by 3/3. We're multiplying by this fancy form of 1. When you multiply things by 1, they don't change. So 3 by 2 is 6. And so this is the same as 2/7. We also do the same or similar thing here, but we're multiplying by 7/7. So that gives us 7/21. We're going to add these two things together to get 13/21. Okay. This multiplication in the top and the bottom is going to be key here, because when we're dealing with rational expressions, well, first things first, let's go with when the denominators are the same. Let's go with 2x squared minus 4 all over x plus 3. And let's do a little bit of subtraction here. It'll also be over x plus 3. And we'll just subtract 4x squared minus 6. Important to note here for addition, less so, but it really comes into play for subtraction, is that the thing I am subtracting is this entire term here, this entire 4x squared minus 6 over x plus 3. And in the same sense up here, when we added them, the bottom stayed the same. So that's, we can at least make that jump right now. The bottom will be x plus 3. That does not change. So then we added the tops here. We're going to subtract the tops here. But we're taking this whole top here from the other. And so kind of what sometimes is useful to do is to just walk yourself through verbally, 2x squared subtract 4x squared. Well, 2x squared subtract 4x squared is negative 2x squared. And then you can say negative 4 subtract negative 6. Well, when I subtract a negative, I end up adding, so negative 4 plus 6 is going to be positive 2. That's very key for subtraction. And in the end, that's my simplified version of this. Now, the last piece is whenever we actually have a rational expression with variables, we have to say our non-permissible values, those values that x is not allowed to be equal to. And in this case, x cannot equal negative 3. And that is the only one. So that's our first example. Our second example is going to be a little more complex. So we'll have 2x over x times y plus 4 over x squared minus 3. So, what to do? Well, first thing we might want to recognize is that 3 can be written as 3 over 1. That's going to help us identify that it has a denominator and that we can begin to play with multiplication to make the denominators all the same. Something you may want to do right away is say, I have an x on the top and an x on the bottom. Maybe they can cancel, and that is true. However, I am going to end up multiplying by x squared again to make the bottoms the same. So it kind of seems a little redundant at this point. I thought about that, but as I wrote across and saw this, I thought maybe there's just no point in doing that right now. So we have to make all of the denominators the same. So I'm going to multiply this by x over x. And that's going to give me an x squared on the bottom to match up with that one. Then I'm going to go over to my second term, and I'm going to multiply that by y over y. Just multiplying by weird forms of 1, right? Y divided by y. And then I'm going to multiply this by x squared y over x squared y. When I do all of that multiplication, I'll get this next expression that looks like 2x squared over x squared y plus 4y over x squared y minus 3x squared y over x squared y. And so now, since the denominators are all the same, I can do the addition and the subtraction. So we'll be clear to write our denominator of x squared y, because that always stays the same. And then we have 2x squared plus y, 2x squared plus 4y minus 3x squared y. They're all different terms, so I don't have to worry about combining any of them. And then this would be our final answer in terms of a simplified expression. Then we must remember to say what values the variables are not allowed to be. So the thing that makes the bottom 0 here is when x is 0, or when y is 0, are non-permissible values. we'll do another example. And this one will look a little different here. We're going to have something like 3 plus 2 over x. Then that whole thing gets divided by 1 minus 2 over x. And in writing this and even looking at it for the first time, you may be thinking, how am I going to add or subtract any rational expressions here? And this is kind of like a format that you may see questions posed in. And so the kind of key idea is to ignore the fact that it's being divided for now and just focus on this top part here. Okay, so 3 plus 2 over x, I'm going to rewrite that as, and we can kind of make that jump, I think, 3x over x plus 2 over x. This is still 3. I've just changed it by making the denominator the same as the 2 over x. So then the top simplifies to be 3x plus 2 over x. So that's our top value. And the bottom value of our fraction here is going to be x over x subtract 2 over x. That's going to give me x minus 2 divided by x. So now I have x minus 2 divided by x. This is slightly difficult to see here. This is the entire point of this format. It's really hard to actually see that both of these terms, the top term and the bottom term, are divided by x. So what I can do is think about the idea that if the top is divided by x and the bottom is divided by x, they're both divided by an x, so I can just cancel that out. And I can get 3x plus 2 over x minus 2. That cancellation is important, though. I'm kind of jumping ahead, but this is fully simplified. It's finished at that point. And then non-permissible values, well, from this here, x cannot equal positive 2. And so far we think, okay, that's the only one, but there is another. And it comes from that canceling out here, but we can also see it right here. Imagine that x were 0. I'd have 3 plus 2 over 0. Well, math says no. Math doesn't like when you divide by 0. So all of this is dependent on the idea that x isn't going to be equal to 0. So, because as soon as it is, you just can't evaluate that. That's invalid at that point. So we also have a non-permissible value of 0. X cannot be equal to 0. At this point, that's kind of all I can say for adding and subtracting of rational expressions. Good luck with your practice, and if you have any questions, feel free to ask.